Hello everybody. This is a guide on how to start the first part of this lab. And the first part of this lab is using a ray diagram to help you find the image created by this lens and this object, which is so far away from the focal point of this lens. So I said more than 2 times, and you can see that the focal point is right here, and that's about the focal length, however long my mouse is moving. You see that this is a couple times over that lens. So it's very far away from the lens, and that's the kind of situation we want to have initially. So the first thing you want to do when finding the image created by a lens is using the top of the object, which we know is brightly lit. I mean, it's a candle flame or it's a light source at your bench. So it's giving off light rays in every direction. Now, the thing is that we don't want to draw light rays in every direction. It's going to be way too complicated and get way too confusing. So what we need to do is prioritize which rays we're actually going to draw. And this goes back to yesterday. We learned 3 extremely important rays in figuring out how a lens bends light after it passes through it. So we're going to use those 3 rays to help us determine where an image is. So now, first of all, how do we find out where the image is at all? An image occurs where the path of light rays intersect, or seem to intersect. The second part, where they seem to intersect, will get a bit more clear when you go to later on situations. But in this case, we want to find out where the light rays from the top of this candle, right over here, intersect on the other side of this lens. So in order to do that, I'm going to draw a line from the top of the candle, and just like this. I'm going to draw it parallel to the main axis. So this is the ray I like to start out with. You can start out with a different one if you feel like, but that's totally okay. So it goes parallel to the main axis, to the lens, and then after it hits the lens, what happens is that it actually passes right through the focal point. I'm going to make my line as long as possible. Okay, so goes from the top of the candle towards the lens, parallel to the main axis, and then shoots through the second focal point. Now remember, this is just one ray of many rays that this top of this object is giving off. So I'm going to choose another ray, and I'm going to draw this in green. And I know that this ray, it will go through, I don't know, the vertex. So there's the vertex, and bam. Okay, so we have a crossing of these 2 rays right around here. Notice how the top of the object, I mean the top of the candle, is actually below the main axis. Okay, that has significance another point. So as a final thing, I'll show you how the third ray works. So, and showing you that it doesn't really matter which 2 rays you pick. You can always get the location of an image just by using the 2 rays. So this one, if it seems like it's coming from focal point 1, it hits the lens and maybe around over here, and then suddenly it goes parallel to the main axis, and you get them crossing just around the same part if you do it correctly. So you know that this image of this object is going to be basically somewhere around in this area. So that's right there is the top of where my candle is going to be. Now let's take a look and analyze what we're going to be seeing here. So this is the top of my candle. This is where it is in terms of an image. You see that the actual image is much smaller than the actual object. So you can label this as smaller. Real light rays are actually intersecting on this side. So they're actually meeting up at a point. The light rays are actually, intersecting. There's no tracing back like with a mirror. So it's actually a real image. So it's a real smaller image. And notice how the top is up here above the main axis, and now the top is over here below the main axis. So then it's upside down. So a candle, which is far away from a converging lens, meaning very far away from the first focal point, should create an image that is upside down, smaller, and real. So if it's upside down, smaller, and real, and you do it on your bench, you should be able to project it on the white screen. try it on your own and make sure you get this down in your own notes. Uh, then continue the lab and see if you can use these rays to help you predict what kind of images you're going to see for other lenses and other setups. Thanks for listening.